The long-distance fishing bite alarm system alerts a user via a wireless handheld device if one of the two fishing rods with a bite detection unit has been bit by a fish. When the fish pulls the line, this is detected by the transmitter units on the rods, and an alert is wirelessly sent via RF to the receiver unit, which alerts the user auditorily and visually regarding which rod has been bit. The project features two identical transmitter PCBs, one for each rod. They feature an SMD ATtiny84 microcontroller with supporting ISP header and reset button, 5-volt power regulation system, the bite detection system, consisting of two potentiometers wired as voltage dividers, with a UA741 op-amp used as a comparator, and an angled header to connect the RF transmitter. The bite detection system uses a custom 3D printed knob on one potentiometer. The line is fed through this knob after the bait is casted out into the water. When the fish pulls the line when they bite the bait, this forces the knob to turn, turning the potentiometer it is attached to with it. This turn changes the voltage available at the negative input of the comparator. When the voltage surpasses the level on the positive input of the comparator, where the middle leg of the sensitivity potentiometer is connected, the output of the comparator goes low. By increasing the voltage on the positive input of the comparator, the sensitivity of the unit can be decreased, meaning the fish must pull the line more strongly in order to trigger a bite, as the potentiometer with the line must be turned more. The sensitivity of the system can be increased by decreasing the voltage on the middle pin of the sensitivity potentiometer, meaning a small turn of the line knob triggers the system. When the knob is turned past the sensitivity potentiometer's position, the output of the comparator goes low. This is detected by the MCU via an analog read, as the low voltage output of the UA741 is close to 2 volts, meaning it is still interpreted as a high by the MCU. This voltage drop triggers the transmitter unit to send a series of pulses to the connected RF transmitter. There are a set amount of pulses sent by each transmitter on the two rods, allowing the receiver to distinguish between them. Once the transmission is over, the data pin of the transmitter is pulled back low. The receiver unit features the same ATtiny84 and power regulation system as the transmitters, with the addition of an angled header to support the RF receiver, a buzzer, and two LEDs. The receiver unit constantly waits for incoming RF data on the data pin of the receiver. Most of the time, this comes in the form of RF noise, and is filtered by the MCU to avoid false triggers of the bite alarm. When pulses from either transmitter unit are picked up, they are counted, and that count is matched to one of the two units on the fishing rods. The MCU then turns on the appropriate LED corresponding to the rod that was bit, and either turns the buzzer on continuously for rod 1 or beeps it for rod 2. These alerts continue until the user presses the reset button and reels in the fish. The units can be powered by high-capacity and lightweight lithium polymer batteries. These two-cell LiPos have a voltage of 7.4 volts and can power the units in this system for very extended periods of time. Each unit is placed into a custom 3D printed case. The transmitter case allows the units to be securely attached to any fishing rod using heavy-duty clips. The LiPo batteries for the unit are tightly tucked underneath between the PCB and the bottom of the case. The receiver case has a similar design. This particular unit uses a 9-volt battery which cannot fit under the case like the LiPo ones, so it is mounted on the back. None of the units are designed to get wet intentionally, but, since they are used near water, the PCBs are waterproofed using acrylic conformal coating. This creates a protective barrier between the components and traces on the PCB and the outside elements, preventing shorts and corrosion. It is applied in a thin layer using a small brush. The RF transmitters and receiver from SparkFun operate on the 433 MHz frequency. They feature one-to-one data transmission, meaning if a low-to-high signal is presented on the TX pin of either transmitter, a low-to-high signal is immediately present on the RX pin of the receiver. There is no data encryption or specific communication protocol. In order to use these units without external software libraries, a communication protocol must be designed along with a noise filtration system. Otherwise, the receiver would not be able to distinguish between a bite on either rod, and the alarm would constantly be accidentally triggered by RF noise. The communication protocol designed involves each transmitter unit being assigned a specific amount of pulses to send with a width of 90 milliseconds when they receive a bite. The Rod 1 unit sends 6 pulses, while the Rod 2 unit sends 12. The receiver presents these pulses to the MCU, which counts them and determines which rod has been bit. At any given time, the data pin of the transmitter can look like this, with constant noise. In order to filter this out, the MCU only counts pulses that are a minimum of 70 milliseconds in width, meaning all the noise is filtered out. The MCU also ensures that any solo pulse, which could never be sent by the transmitters, which send a minimum of 6, is ignored.